All right, so here we're going to go through the summer calculus survey for AP Physics. Some of your answers may be slightly different for this first one. So as far as the understanding what a derivative actually is, hopefully you said something along the lines of slope, right? Derivative is the slope of a function. You should be able to look at a graph, and if you were to draw a tangent line at a certain point for some function, you would have the slope at that point, and that is essentially the meaning of a derivative. So let's move on to part 2. So I'm given this function, y equals 3x to the 5th plus 7x to the 4th minus 2x squared plus 4x. Part A says find dy dx, and the understanding of this is the derivative of y with respect to x. So, in case you've forgotten, the simple formula for a derivative is if my function is f of x equals x to the n, then the derivative of that function with respect to x would be n, so I take the exponent and make it a coefficient, times x to the n minus 1. So we can apply this really easily to this particular function. So we have y equals 3x to the 5th plus 7x to the 4th minus 2x squared plus 4x. So my first term, if I want to find dy dx, is taking this 5 and making it a coefficient. So I would have 5 times 3, and taking my power and reducing it by 1. So 5 becomes a 4. Similarly, for the second term, 4 makes a coefficient, times 7 times x, now raised to the third. Here we have 2 from the exponent coming down, times 2 times x, because 2 minus 1 is 1, plus here I'm just taking down the 1, so it's the same as 4, and then 1 minus 1 is 0, so my simple x term goes away. So to simplify, we have dy dx equals 15x to the 4th plus 28x to the 3rd minus 4x plus 4. So part B is to find d2y dx squared. So this, in case you're unfamiliar with this terminology, is the same as taking the second derivative, or the derivative of the derivative you had found in part A. So, along the same process, I can just do this right below. I would take the 4, multiply by the 15, and I get 60x now raised to the 3rd. 3 times 28, which is 84. Now reduce that by 1, squared, minus 4. And so this is my second derivative. Moving on to 3. So now I'm looking for y prime if y equals 3x squared minus 4 in parentheses to the 5th. So again, we're looking for the first derivative. This particular one uses the chain rule. So if I have y equals 3x squared minus 4 raised to the 5th, I do something similar to question 2, where I'm going to take this power and make it a coefficient. So I'm going to multiply by 5, and then I'm going to take the exact same set of parentheses, and I'm going to reduce that exponent by 1, so 5 becomes a 4. Then we have to use the chain rule, because this parenthetical thing is more complicated, so we need to find the derivative of that interior. And so this then becomes the derivative of the interior, which is, I'll do it over here, 3 squared minus 4. So I'm going to take the 2, multiply, 2 times 3, times x, and then the 2 becomes a 1. The 4 goes away, there is no x term, so I have 6x. So the interior derivative just becomes 6x. And if you left it like this, that is perfectly fine. You might want to go one more step and say that I have 30x times 3x squared minus 4 raised to the 4th, but that is as far as you need to go.